Hi students, welcome to this video. In this video, I'm going to explain Riemer-Tiemann reaction, which is an important naming reaction. Here, I'm going to explain the mechanism of this Riemer-Tiemann reaction also. First, the reaction of this Riemer-Tiemann reaction is phenol, Riemer-Tiemann reaction. Here, phenol in the presence of phenol with chloroform and sodium hydroxide, the product formed is salicylaldehyde. The product formed will be salicylaldehyde with NaCl and H2O. So this is what the reaction, Riemer-Tiemann reaction. The main product formed is salicylaldehyde. So this reaction we are going to see with the mechanism. So the first we'll see stepwise. Okay. So step 1, reaction of chloroform and sodium hydroxide. Step 1, reaction of chloroform and sodium hydroxide. Listen carefully, students. Here, chloroform will react with sodium hydroxide. Here actually in that reaction with phenol, we are taking chloroform and sodium hydroxide. So first, the reaction will be between chloroform and sodium hydroxide. Here, in the sodium hydroxide, I am going to take only the nucleophile, that is OH. Okay. So here what happens, this OH combines with this H and will get removed as water, and the remaining your product will be CCl3, and this CCl3 will get decomposed into CCl2 and Cl minus. So here this CCl2 will be having one lone pair of electrons. So this is dichlorocarbene. Dichlorocarbene. And this is chloride ion. So this formed dichlorocarbene only, it acts as an electrophile here. So this acts as an electrophile. Okay, so this is what your first step, students. Second, next we'll go to step 2. So in the step 2, first phenol. The stabilized form of phenol is your phenoxide ion. O minus. So this is phenoxide ion, which is the stable form of phenol. And why this phenoxide ion is stable form? Because of phenoxide ion, it will be having more stabilized resonating structure. Why this phenoxide ion is stable one? Because of more stabilized resonating structure. Okay, next, to this phenoxide ion, dichlorocarbene attack will be there. This dichlorocarbene only will act as the electrophile which attack this phenoxide ion. So this attack will be there in any position, here, here or here. Any position the attack will be there. So after the attack of this electrophile to this phenoxide ion, the structure will be, the product will be same. Here the same bonds I am writing, and here what happens? This attack of dichlorocarbene to this one means what happens? Here the electrons will get transferred here. So here your product will be, it will become double bond O, and attack of dichlorocarbene. Here what happens? Two double bond are together. Usually two double bonds won't be together. So what happens? This bond will share here. So I'll write the product of sharing of that bond. So here the bond, same bond I am writing here, and here also I am writing the same bond. And what I told you, there will be a share of this bond. So here it will come, the bond share will be there, and the hydrogen atom which is present here also will it will be shown here. Okay, so here what happens? This carbon with Cl, 2Cl, the CCl2 only I had written like this. Okay, and here the same double bond O will be there, and one lone pair of electron is there in this electrophile. So that lone pair of electron I had shown with this negative symbol. Okay, next, and this state is the intermediate state. This state is the formed one is your intermediate state, and this negative charge will be having it will be attached to this hydrogen. Okay, and there will be a transfer of bond from here to here. Again what happens? The double bond won't be together. So here also the bond shift will be there. So after this, the product formed will be like this. So the same bond I am writing here, this bond I am writing here, and what happens? There will be a transfer of bond from here to here. So that one I am showing it here, and here what happens? The C and H will combine and it will form like CHCl2, and here the shift. So here it will become O minus. Okay, in this stage I am going to introduce NaOH. How many molecules of NaOH I am going to introduce? 2. So here I am going to introduce 2 NaOH, and here this will get split into Na plus and OH minus. Here split into Na plus and OH minus. And here what happens? This Cl2 is also a nucleophile and OH is also a nucleophile. So this OH will take the place of this chlorine. So here the same bonds I am writing it here, and same CH also I am writing. Instead of the Cl2, OH will replace that Cl2, and this O minus will be there in the same position. Okay, so both the nucleophile get exchanged here. After, what happens? This OH2. So if you take this OH2 I am writing like this. Here what happens? H2O will get removed. So I'll write H2O will get removed. And what else is remaining? CH and one oxygen is remaining. So your product will be same, this bonds and all, it is same, and O minus also is same, and I am going to write CHO here. Next, in this stage, I am going to introduce H plus. So here H plus and this O minus will combine, and the product formed will be salicylaldehyde, OH and this CHO. Product formed will be salicylaldehyde. So this is how salicylaldehyde is formed from phenol, and remaining Na plus will combine with the chloride ion which is formed in the first step, and it will get removed as NaCl. And here removal of water also I had shown. So this is what the mechanism of Riemer-Tiemann reaction. Riemer-Tiemann reaction, phenol with chloroform and sodium hydroxide, salicylaldehyde is formed. Thank you students. In next video, I'll meet you with the other naming reactions.